Hey, my Tesla friends, I've got a real good treat for you. I just interviewed Chris Lawrence. He's one of my co-workers where I work at Nutritech, and he took a nano class, I don't know what it's called, but on autonomous driving, and actually developed his own sample autonomous driving software as part of the class project. So I interviewed him on his class that he took, also just about autonomous driving, and then he got to test drive the my Model 3. So I think you're really going to like it. Here it is. Okay, I'm here with my buddy Chris.
Hey guys.
Chris. Chris is an autonomous software developer, took an official class. What was the class?
Through Udacity.com, led by Georgia Tech and Stanford University.
Very cool. And what did you have to do as part of the class?
It was a lot of machine learning and visual, computer vision items, neural networks to identify stop signs and road signs and things like that. Control systems as well. So I haven't driven a Tesla yet. So this is pretty exciting. The only car that I've driven that has anything like what the Tesla does is a Volvo that kept trying to drive me into a ditch. So I'm hoping
with some software running.
Right. Yeah.
Your software? Or?
No, not my software.
Okay.
No. We did. We ran our software on a Lincoln sedan. A lot of virtual testing too, but then on a Lincoln in a parking lot. The video clip that you saw was the final one for identifying stoplights.
Stoplights.
Yeah. That was actually pretty interesting because on a bright day, the stoplights are harder to see because it's just.
Okay. So I'm gonna let you figure it out since you're such a techie.
Okay, so the fascinating interface, just because you don't have the standard dashboard stuff that we're used to. So we have this huge screen. We should probably just turn it down or off just so it's not messing up the audio.
Right.
Yeah. Okay, so huge screen, awesome control systems. So many options. Oh wow.
Yeah. Let me turn off the. There we go. So that's
okay. So there's the map. Just want to see what this looks like. So just a huge number of settings and options and adjustments you can make all through the screen interface.
Go ahead.
Which is pretty good. So the limitation of some of the earlier screen interfaces is the screen was so small and it was only doing one thing at a time. And so I was in a car the other day, a rental car, turned the car on, the screen was booting and the sound from the stereo was at full volume. We were all blasted out because the screen wasn't responsive yet. But this has such a large amount of screen real estate. You've got different panels and things. How has it worked for you?
Great. And feel how secure it is. It is like rock solid to touch and work on, which is really cool. It looks like it's flimsy and
You'd think that it would wobble, but it clearly is pretty solid. So we've got 2 stalks, windshield wipers and lights, and the main driving controls, it looks like.
Correct.
So up is reverse, apparently. Let's find out. Nice camera.
Yeah.
So my goal for today is to not have any sort of unintended incidents. Is there a like a extra brake that I need to turn off or anything?
Nope.
Okay. Get a little bit of air going since it's a bit warm today.
Great.
So I'm gonna see what happens as I get a little closer.
Let me turn this off. All the sensors show up around the car.
Okay, so I've got a warning that's partially hard to see. Let me turn that off. Okay.
Yeah.
So I can see that there's.
And it changes colors as you get closer and closer. So you figured out drive.
Figured out drive. Drive is down.
No. Yeah.
Freaked you out a little bit.
Yes. You're the one that's supposed to get freaked out. I mean.
Okay. I like that the mirrors auto adjust as you are going from drive into reverse.
Somebody asked for that, and I have to make a video on it.
Okay. Because that's pretty handy that you get a better view, I guess, of the ground when you're backing up. Whoa. The regen braking is strong. That was stronger than I was expecting.
You can turn it off, or put it lower, which makes normal car. But I keep it on all the time. If you want to, I can let you feel it.
Oh, okay. Just see what the difference is.
Yeah, so that's now normal, like a normal car.
See what happens. And I like it this time. Okay, so you can still feel a little bit.
Right. It's less. Yeah. I'll turn it back on. And the other thing you can do is put on creep mode, which when you come to a stop, if you just stop and let go of the brake, the car just sits there.
So then the creep mode is more like an automatic transmission.
Yes.
Where it'll just slowly
creep forward. Right.
So it's definitely very smooth. Figuring out when to let go of the gas because of that regenerative braking.
Yes. Takes a little getting used to.
Yeah. Otherwise, though, steering feels smooth, throttle feels smooth. The stalks do a good job.
If you make it right here to get away from traffic, what do you think?
Yeah, I was thinking something simple.
Okay, try to punch it all the way to the floor. All the way to the floor.
Oh my gosh, I don't know if I can do that. Whoa! I did not make it all the way to the floor.
And if this shows up, you can double tap on the right side down, and you're in a full automatic now. Let go. Everything.
I'm going to hover.
Okay, yeah, hover. And your feet keep let your feet hover. You'll see it stop.
Does it gives audio alert if it loses lane lines or something?
Yeah. So those are the lane lines.
And something to note is that there is no lane line on the right, but it is identifying the curb properly.
Correct. The old one didn't.
Okay.
Now, as soon as you touch the brake or steer, you disengaged it.
Okay.
So you just disengaged, yeah. Which is just what you normally want to do.
If,
you could have next light, just let it start up again.
Okay.
So again, double tap. We got to wait for this to show up. Once that shows up, now double tap.
And we've got an exit lane here, so this will be a good test.
Yep.
So we have an exit lane on the right now. It should lose the line. It did not.
No.
I am impressed.
Yep. The other one would have gotten a little confused. Sometimes it would go right, sometimes it would go left.
That's what happened with that Volvo about 2 years ago. Is it kept trying to take exits.
This is a good example. No, this is a good example where you're going to have to brake.
All right.
What I'm hoping is that, because they definitely, I bet, already can sense and read stoplights and stop signs.
Okay.
So I think the next progression for autopilot is to just stop, right?
Yeah.
Require you to start up.
Oh, I see.
Okay, but
when
just
it turns green.
Yes.
Because you'd still have to make sure that it was safe.
Right.
Depending on the level of object recognition around you.
Right. I'm just thinking the stopping part right now, which is you can use autopilot on local roads very conveniently, and if there's a car in front of you, everything works perfect.
Right.
But when there isn't, you have to take over at every stop situation.
And the stoplight was the final part of the program was the test, and that was the part that was significantly more difficult than we expected because when the conditions were good, it was really easy because you have a nice bright light, you've got a shape that you can use to identify that it is a stoplight, and if it's the top one versus the bottom one, what color it is. You have all these things you can use to identify lights. But if you happen to be facing towards the sun, and the sun is behind the stoplight, and there's dirt on the windscreen or something, so it's slightly harder to identify, the standard neural networks against just straight video would not always pick that up properly. And so we ended up having to do a lot of data manipulation of the image before trying to feed it to the neural network.
You know, that would have been a good test right there.
Let's see what it is.
Yeah, let's turn around.
Okay.
Go in here.
Go around.
Yeah, I don't know. And yeah.
Actually, maybe I'll say.
No, let's see. Yeah, you can make a right and a right. Because I'm curious if it would. Yeah, that's the. Did you push the button in?
I did, by accident, yeah. Made the windshield wipers go. So the solution for the stoplights we finally did is no matter what time of day it is, day or night, the stoplight luminosity is always the same. And so we adjusted the video brightness to expect stoplight level lighting. And it worked well for brake lights as well. So we would end up basically needing 2 video feeds. One for object recognition of things that are reflective surfaces, and then a second video feed of things that we expect to be glowing, like stoplights and brake lights. Maybe reflectors on bicycles, although we didn't test that. So it was a tough class. I learned a lot, particularly about setting up development environments and tearing them down again. Where are these guys?
I think I'm pretty sure it's to the right. Is it down there?
I don't see him. So
Yeah, here he is. Okay. So
Good,
as soon as you
So we're
get
gonna test
on,
something
watch
here.
this and double tap. Come on. Engage. Okay, double tap.
Okay, we are testing right now. There's a truck here. Oh, it's speeding up a little bit.
I can slow it down. Ah, shit. Did you steer?
I did not.
Okay.
But, oh, now I am. Okay.
I don't know if it would have handled that.
I'm not sure. So there was a lane line, but then a truck sitting on top of the lane line, as well as a guy in a lawnmower.
Right.
And I was not brave enough to fully allow that.
Okay, double tap now,
Okay.
and you should. Okay, so let it do its thing here. Yeah, I usually just keep my hands close, and you can actually. There's a if you feel the steering wheel real softly wiggle.
Okay, I'm gonna wait for it to start. Okay, yep.
Yeah, you see that? That was cool, wasn't it? When you don't touch the wheel, or your hands are on the wheel, but you're not actually giving it any resistance at all,
Right.
Within 1 minute you'll get a warning. And what you have to do is sort of just softly wiggle it,
Okay.
which doesn't pop it out of autopilot. It just acknowledges you're alive.
Gotcha. Just enough. So
Right.
that where they're.
So there it is. That's the warning. So now you have to
Okay.
just wiggle. You have to wiggle a little more, a little harder, until this warning goes away. A little harder.
There we go.
You sort of get used to it.
Yeah.
What I've learned is what you can do is just keep a little turn pressure on the wheel at all times, and you'll never get the warning. But you can't give it too much because it'll pop out.
Interesting. Okay, that was a good test. There was an exit lane, and the lane line was hidden by the car ahead of us. It started to go just a little bit, but then it immediately saw the lane line and it straightened out. So that was pretty impressive how quickly it picked up on that lane.
Make it right here.
Do you hear about the Tesla driver that got in trouble? I think it was in the UK.
Yeah, I jumped
in
in
the passenger seat. I guess he was leaning over and pulling the wheel occasionally to keep it.
I'm glad that happened because I was probably going to eventually get to that point, and I realized maybe I shouldn't.
No, not yet. You could do it in one of. Am I allowed to say other brand names?
Yeah, right.
In this one.
Okay, so you can actually engage it when you're stopped. If you come to a full stop.
It looks like it doesn't see the curb.
Let go of the brake, maybe. Yeah, double tap.
Okay.
And now it's going to pull up just to.
So there's something sticking out.
Notice how wide. It'll be fine. See how wide it is. What's really cool is it never used to fully sense the road surface, and with the latest update, you're getting much better surface recognition, road surface recognition, with just curbs, and I think it's a small point, but roads proper road surface identification is really, I think, key to eventual self-driving.
Well, you have to be able to avoid not just physical objects in the road, something that sticks up, but also holes in the road, potholes, and not driving off a cliff.
Right.
Things that do require recognizing the road surface.
And so the latest autopilot, basically, like under the hood, it is getting ready for self-driving.
Yeah.
That's what I've learned.
Yeah, definitely. I mean, they've engineered the hardware with that in mind. Definitely. And the
this is actually
it's doing that pretty well.
Yeah, right. So,
okay, now let's see. That was perfect.
Yeah.
And
that's not trivial. That's not a trivial. That right there was not trivial. That was a
curb to an open area with no lane. What's that?
You gotta wiggle. If you get three, so you get the warning down here, then it starts flashing, and then it beeps. If you get 3 occurrences of beeping, meaning you haven't responded in, I think, 90 seconds to the warning, it disengages completely. So,
and then at that point, from what I've read, it will slow down.
Yes.
And if you're on a highway, maybe pull over. I guess.
It doesn't pull over, it just slows down and puts the flashers on. I made a whole video on that.
And that's actually good. There's been a couple cases where someone's had a medical condition occur.
Right.
And in one case, at least, they were still sitting, or their foot was still pushing the gas, so they were not on the road anymore, but still going at a high rate of speed. And people actually realized what was going on and helped stop that car. But if the car knew to stop itself, that would be excellent.
So up and down on this wheel is your speed.
Okay.
And left and right is following distance. So if you toggle that left or right, you'll see the following distance adjust down here.
Okay. That's nice. And that's an easy interface too.
Yeah, that was a software update. You used to have to do it through clicks over here, and they just added engaged.
This makes me feel like all my years of video gaming will come in handy in the future. 2 thumbsticks.
That's fun. It's freaky to get used to trusting that it's going to stop.
Yeah. That was something else that happened with the Volvo as I was on a 2-lane highway. It was following and doing a good job, but at one point there was traffic in the left-hand lane, and it was clearly not built at that time, again, it's a couple years ago, to track adjacent cars, traffic in adjacent lanes. One of the people in that other lane decided to change lanes right in front of me.
Let's pull them right up here. Actually, try the blinker. Try the blinker. Just the blinker. Blinker.
Okay, that car is now pulling.
But yeah, just be careful. But it should. Now I don't know what. We're not on a highway, so it might not do it.
Yeah, I don't think it's doing anything. Or it doesn't like that car.
It doesn't like the car, probably. So let the car pass and then make it pull over. On a full highway, you hit the blinker, and as long as it's open, it will change lanes for you. And what's nice is I believe in the Model 3, little things, it turns off the blinker after it gets in the lane. The Model
S, an important part of the whole process. You got to finish the job.
In the Model S, you have to turn off the blinker.
With the Model S, would change lanes for you. You turn on the blinker, and then when you were done, you just turn it off.
Right. Yeah. So they've slightly tweaked it. It's so cool how every month you get a little tweak to something.
But it's pretty neat. Just the fact that you can do over-the-air software updates to a car. It's pretty amazing.
And I talked about this earlier, but just having a universal wheel and then being able to retro what it does. So many years, for years and years and years, every little thing like that, like adjusting your buttons on your wheel for cruise control. Right. It was a closed system. Yeah. The buttons were defined. It was going to be that. They were never going to change. Yeah. Right.
I have a aftermarket stereo edition, and so the buttons that I use to control that are labeled for something completely different. My wife borrowed my car, and she had no idea how to make anything in the stereo even work, because you have to hit like the CD player to make the radio turn on. So yeah, something with control and then visual feedback on the screen, so that if you didn't know what it did, you could hit the button and then find out.
Right.
Worst case scenario, if you didn't know already.
But the whole car is like that. Every like mechanical thing is really, instead of just dedicated to some other, controlling some other specific piece, I think everything just goes to a computer, and then the computer has control of all kinds of things, right?
Yeah.
And so they can repurpose things at will. Not too many cars are designed that way. You know, they have dedicated subsystems.
And they'll communicate across, I think it's the CAN bus. But then, yeah, each system is kind of independent and dedicated to that purpose.
Right.
There was something in the call that Elon Musk did yesterday about ideas for the Model Y, and part of that had to do with the interconnection design, but I'm not sure if it had to do with the computer stuff or specifically just about the DC batteries and the wiring necessary for that.
The DC batteries, I don't get it.
Something about this is not in my area, so more of the hardware engineering of the electrical system. Something about the current design requires a significant amount of wiring, which is difficult to automate, and so part of the process of what they're hoping to do for the Model Y is change that electrical power.
You weren't.
It's an electrical steering.
Yeah, see how wide it's identified the road? And then watch. This is really cool.
Skinnier.
Yeah.
Right here it should be getting skinnier. Yeah, you can actually see it.
Isn't that cool? I got to do a video on that. That's a perfect example of that.
That's a good spot for it. I actually haven't been paying attention to where we're going.
Right.
I'm not really sure where we are right now. I've been here before. We're not too far away.
Yeah, I gotta believe, because that Y is insane performance. They must. I've read that one of the key core technologies of the battery systems are impressive as they are, but to find the most efficient way to get the energy out of the batteries into the motor to be able to get the performance that they get.
Is it for the Roadster? The new
the new Roadster.
Okay, yeah.
1.9 seconds 0 to 60. The amount of current that they're extracting from those batteries, it's really pretty impressive engineering to do that.
I really would like to get one of those. I think it would, in reality, be that I couldn't even feel comfortable getting this pedal to the floor. So that would be, I'd have to know someone who owned an airfield or something before I'd be able to use all of that power even once.
Right. Well, I think the game, like I went to the Tesla store to let it take a test drive in the ludicrous mode model, which is, I think at the time was a P90D, and 0 to 60. I think back then the P90D was doing 3 second 0 to 60, and man, it was fun to launch.
Oh, I'm sure.
I made a video. I had a video of it. Yeah, that's the warning. So, yeah, the warning used to be every 3 minutes with the Model S Hardware 1, and with the Hardware 2, they're down to 1 minute. So they really tightened up the need to make sure the human is driving.
And I think part of that's the discussions they've been having with the Transportation Safety Board.
Possibly, yeah. Now, what Cadillac did is they put a camera right here, and they check that your eyes are forward. And so they say they're the first hands-free car that you got to bring. Because Tesla requires you to give feedback through the wheel.
And I actually think that's probably better, because even if your eyes are forward, if your hands aren't anywhere near the wheel, it's going to take an extra quarter second to grab back on again if you have to take control.
Now, we found a camera here Okay, but that they say it's not engaged yet.
Okay.
And the rumor is that it's not. Well, I guess it could be used again. Great example of repurposing. I guess make it right here.
Yeah.
But they said maybe for the ride sharing, you'd be able to see people in your car, monitor the people using your car.
Okay.
In the ride sharing.
That's going to require quite a bit more autonomy level if you're having your car go out and pick up passengers completely independently.
Okay, so why don't you come to a stop? We'll do a 0 to 60 test.
Okay, this is a good spot for it.
Yeah. And I'll just count out 1,000. Ready? You gotta put it to the floor.
Okay.
Ready? 1, 2, 3, go. 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. Ah, you left up.
I left up a little bit. That is insane. That's like a roller coaster starting up. Amusement ride, I think I said in the first time I was in it.
I just wrote that in a comment that everybody describes it as a roller coaster and an amusement ride.
It's that first couple seconds of your head goes back in the seat and you feel all those G-forces pushing you backwards as the car is moving. What's impressive too is I could feel the tires just slip just the slightest bit.
Right.
And so I guess there's some
algorithm
traction control to make sure that it's keeping grip on the street.
Yeah.
It's a little gravelly here.
Yeah, they show the Tesla beating these roadsters with these huge rear wheels, right? With 800 horsepower engines.
Yeah.
Right? And they have to do that because the engine's putting out so much torque that the wheel,
Yeah, it just overpower the friction.
And the Tesla's with a little, like these tires, right? And it's still out, it still crushes it.
That is impressive. Rented a car a year ago and just happened to end up with a Challenger. It was the only one they had. And at some point, empty road somewhere, I'm like, I'm going to find out what this can do. 0 to 60. It was impressive, but nothing like that. That's a lot more impact in terms of how quick it really speeds up.
Yep.
Yeah.
And it just keeps going. I mean,
you get the same amount of that feeling when you're going 60 to 65 as 0 to 5.
Right.
That's the advantage of having the electric motors instead of the...
Yeah, who would have thought, a little electric motor can outperform these massive 8-cylinder, turbocharged.
I meant to look at the range to see what range impact we had. How's your range performance been so far?
It's great. I mean, it's, even with the 200-mile range model that I used to have, I rarely ever come close to using it in a day because you always leave the house, unless you forget to plug it in, you leave the house with a full charge. So my full charge, I think, is 276 because you do 90%. The charge is used to be right there, but I think it's now is charging. Lights, locks. It used to be up here. It's not that because that's the model. Oh, you touched the battery. Jeez. It used to be a bolt up here, and so they've taken things. So my charge limit, you set it at 90%.
You don't want to overcharge.
Yes, lithium-ion batteries, right?
And then, do you have a supercharger?
No, just a 220 plug. The dryer outlet. It does 40 miles of charge every hour, and it's way more than enough to charge overnight.
There's some announcements from some of the other manufacturers 2 weeks ago about some of the super high amperage charging options that'll be out soon. Things where the chargers that they're going to start building this year have no cars that can charge that fast. You don't want to overwhelm the battery, so basically all the cars for the next year or two are going to have to phone call.
It's a solicitor.
Are going to have to go slower, charge slower than the charters.
By the way, you know what I wanted to tell you, because we had talked about it earlier. The Israeli company. You gotta go further. And then, I would stop. And back up, maybe straighten it out. The Israeli company, BMW, signed with this Israeli company for a solid-state LiDAR.
Oh, okay. That's gonna be huge.
Maybe that car was just crooked.
That's my car.
Oh, okay.
Awesome. Let's see where actually, I think I wasn't quite straight yet.
So they said they're shipping now. The Israeli company.
Really?
If you go to their website, I forget the name of the company, but stop, and press the button to park.
Yeah, because I've been keeping tabs on a couple candidates in that area, because Velodyne's spinning LiDAR is really good. The most expensive ones will price you out of being able to put it on a car. So I mean, that's why Tesla doesn't have LiDAR right now. It's just the expense.
Well, he actually, no, I don't know whether it's that. What I've read and I heard him speak was that he felt that the image recognition is more important and going to pay off in the long run when they get it perfect. With image recognition with radar, that combination he felt was going to be more beneficial in the long run.
I mean, we do have binocular vision, and we manage to identify objects. We are far from perfect at doing that, certainly. So I'm a big proponent of including LiDAR data, because it gives you that three-dimensional model of the world that you can't get with just vision. Helps take care of certain edge cases as well. There was one that came up where a van that was driving in front of one of the training cars had a big applique sticker of people riding bikes, and the software identified both the van and the bikes and completely confused what it was and how to expect behavior.
And the LiDAR would have just seen it as a box.
Right. And so it would know by doing sensor fusion, merging the data from the LiDAR and the cameras and radar and microwave, whatever else you might have.
Right.
You get that much more full-featured concept of the world. And
is it true that the hardest part of autonomous driving is the not the correct identification of things, but not misidentifying something, just like you described? If you have like an overpass, you're going under a low overpass, not identifying that as a car, or something.
And there's sort of two levels of identification. You've got the identification of the fact that there is a thing there.
Right.
So with binocular vision, you can identify through parallax between the two cameras a fair amount of that. There's still some difficulties in handling shadows and making sure that a shadow on the road isn't actually a three-dimensional object of some kind.
From the image perspective.
From just the image perspective.
Right.
But once you can identify, yes, this is a physical object that we should not run into, then the question of identifying what the physical object is. Is it a car? Is it a person? Is it moving or not moving? And that can be somewhat hard to distinguish sometimes. Not if it's moving or not moving. Identifying a non-moving object when it's close to something else, and that was involved in some earlier accidents with assistive driving technologies, is if there's a car that's partially on the side of the road, right next to a barrier, it kind of blurs into the barrier from a data perspective. It makes it a little harder to identify and differentiate and then make sure you can avoid those items. The identifying that it's a car, a person, something else, the actual classification of the items into specific types of objects is important for then doing predictive behavior analysis and projection. So if you know that it's a car, it's probably going to go straight. It has a chance to go right, chance to go left. It's not going to suddenly jump up in the air, spin around, and come directly at you. A person will behave differently. An animal will behave differently. So when you're predicting where those things are going to go with some general likelihood percentages, that's when you want to know, what is it? Is it a car? Is it a bridge abutment? The bridge abutment's not going to move.
Right.
So if you know it's a bridge abutment, you have a pretty good idea of what to expect from it. But in any given case, you know that it's a physical object that you shouldn't run into. So as long as you've got that, we We know it's a physical object. It's currently not moving, so we're going to avoid it. That's sort of like the core safety step. The second part of saying that's a bridge abutment, we predict it's not going anywhere, will aid in your ability to do a better job of steering and picking a good lane choice.
Well, just discounting it. So being able to quickly discount as many things as possible and really account for the critical things.
And in that case,
right?
I wouldn't even discount it. Like, your subconscious mind would handle that. You wouldn't necessarily be consciously aware it's there, but your subconscious is still handling the existence of the bridge abutment and your active avoidance of it. From a computer perspective, we don't have that subconscious-conscious divide. So you're dealing with everything. So in that case, you'd still want to include it in your data set as something to not run into. And part of your
Well, that was
planning.
my exact point. My point was, I think the challenge in AI, at least in autonomous driving AI, is to be able to properly discount the things that really are not a problem, so you can focus all of your compute power on the things that could be a problem.
And you definitely will percentize the important items. And so putting, when you're building your cost function for determining whether decision A is better than decision B, you would predict out and say, if we're going to pick path A, and that involves going to the left-hand lane, there's a car there, but it's far enough ahead. You do all these calculations, and there is no bridge abutment. Then path A is pretty good. If you are picking path B, and it looks like there's a bicycle or a pedestrian that might be in the way, you would add a huge amount of cost to that choice because accidents are to be avoided no matter what. So as you're determining what the best options are, bridge abutments and things that you can sort of discount, they're not necessarily being ignored or discounted.
They're just so low that they're not.
They're so low on the choice of good ideas. Running into the bridge abutment costs 10,000 points, and you don't want to do that. Everything else is going to be in like the 1 to 100 range. Crashing is really low on the list of things. So anything that would result in a crash just basically gets culled from the selection list right away.
Oh, low, not, I see.
Yeah, so it's a high cost, but then on the list of good ideas, it's low now because the cost is high. But there's still the question of what happens if there's no good choice.
Right.
So what if the option is you run at 5 miles an hour?
You're going too fast. You're going too fast to be able to stop.
Right.
Right? Is that the situation?
Exactly.
Yeah.
There's no way to avoid some kind of an accident. And this is something that has been talked about, and there are discussions about it, but I don't think there's really a decision, particularly industry-wide, of how to handle.
But humans have to make that decision all the time.
All the time.
Right.
And it's never even a good decision. I mean, you've got a deer. We're in Pennsylvania. There's deer all over the place.
Yep.
If you've got a deer
oncoming traffic
versus oncoming traffic, and you can't avoid one or the other, and there's just nothing else to do, the deer, unfortunately, is probably the better choice of those two. That said, deer are still pretty pointy, and
they'll come through your windshield.
They'll come through the windshield, possibly.
Right.
So it might even be that a human recognizes those two choices and doesn't realize there's actually a third choice, because you've only got that split.
What's the third?
Second. Maybe the third is to go onto the sidewalk.
Oh.
Maybe if there's no telephone pole there, or if it's a front yard with no sidewalk, you can manage to come to a stop.
Completely off-road, which is one of the criteria that you're not supposed to do.
Right. Like, that costs 10,000 points, too, but, like, the deer is 10,001 points, and the oncoming traffic is 20,000 points, because you've got other people involved at that point.
Right.
But then if you're thinking about programming into the software the possibility of running off the road, then you have to not only account for the fact that there are pedestrians near the road on sidewalks,
But
there are people gardening in their
see
front yard that you need to be aware of.
But no, that's a really good point. You've got a deer in your lane still. You've got oncoming traffic left, and you've got an open off the road to your right. Will it be able to say, okay, I'm going to go off the road into somebody's lawn because I know it's less.
That might be the best, and that's going to
maybe even to a soft fence.
Possibly.
Right?
Yeah, well,
but
then
still,
you have to know what the difference between wood and concrete at that point is. Right. But then also, back to your point at the very beginning of this, the road condition question. So if you're thinking about the possibility of purposefully coding it to go off the road, it needs to know, is there dirt there? Is there a swale or like a ditch of some kind?
Right.
It might not be flat. So if you're going to code that in, suddenly not only are you identifying lane lines and road road surface. In
Sure, right.
California.
Okay, so on the right you have a cliff, you got a deer in front of you, and you've got...
Well, you're in California going around those curvy roads where it's
right.
literally a cliff on one side and a vertical uphill cliff on the other.
Right.
You definitely don't want to include the possibility
I think
of
the
going
good
off-road.
news is that the braking systems are so good these days that it may be okay, I'm going to hit this deer, but I'm going to be able to get down to 7 miles an hour by the time I hit it.
Yeah.
Right?
Oh, yeah. That's a much better accident than a 35 mile an hour.
Correct.
And then with the...
Now, whereas the oncoming car on the left side is coming at me,
right.
and even if I'm down to 7 mile an hour, I still have a 57 mile because he's going 50 miles.
Right. And just with the auto braking aspect of the Tesla, the NTSB report was saying that when you turn auto braking features on, accidents go down by 40%.
Wow.
Just because you've got that
better braking,
quicker half second to start braking, whereas in your mind when you're driving you're like, oh, do I need to brake right now?
Right.
And that time that you're thinking about it is being used to actually brake.
Well, I wasn't thinking of that. I was just thinking the braking systems, when they're engaged, are getting so good. I had a pretty tough situation where somebody cut in front of me, and I slammed on the brakes on my Model S, and it pulsated so perfectly that I swore any other car previously that I've ever owned wouldn't have been able to slow down and miss that car.
Even with the anti-lock brakes they have, it still would have probably locked up or something.
I think the Tesla anti-lock brakes is a little bit, it was just impressive to see it. And maybe I just never had such a close call before, but man, it was impressive at how quickly I came to a stop and I missed an accident.
I could imagine that. Just this short drive, it definitely felt between the regenerative braking and then actually applying the brakes that there was a lot of stopping power available. So given how fast it can speed up,
right,
that's definitely a good thing to have.
Right. What else did I want to ask you? There was something. I can't remember. Oh, so tell me what you thought of the car.
So it's a short drive. We didn't do any highway miles. We were on surface streets, local roads, curvy roads. Very impressed with how good the surface street lane line identification worked. Right. Particularly that one instance where there was a blue car. That too, actually. Where the blue car was hiding the new lane line. So there was a right-hand turn exit. So the right-hand lane line went over to the right. And then, as far as the car's visual system was concerned, there was no lane line in front of us because there was a car in the way. The car kept moving, and as soon as that lane line became visible again, within, I think, less than a second, probably half a second, it had picked up on that lane line and immediately had corrected the steering.
Shuffle,
And we didn't even make it out of the lane. Like, it started going slightly to the right, maybe a couple inches, and then it had corrected itself already. Right. And I was fully expecting that test to fail as soon as it started, but it handled it.
The previous software, you would get these jerky back and forth, and the other big thing I've noticed is all corrections are really smooth now.
Okay.
More like a human would do.
And that was part of the exercises we did at the very beginning of that class that I took, was handling the nausea factor when you're dealing with control systems, because you can make the car do really abrupt direction and speed changes, and then everyone in the car will be sick. So
what did you have to do in the class? You had to program a full car?
Correct. So we were programming, we weren't doing everything including the touchscreen controls, but we were programming, first off, the video recognition, the sensor fusion of LiDAR and radar and camera input, identifying objects, then translating that into control sequences. So steering control, throttle control, braking control. There was also a section on predicting other vehicles, identifying the vehicles, and then making predictions about where they're likely to go, right lane turns, left lane turns.
So what was the test? What was the...
Well, and then part of that too was doing things like the control that you're talking about, where you have that sort of jerky adjustments, and our early builds were pretty nauseating. but then applying a spline method. So instead of saying I'm going to turn from lane 1 into lane 2 and then just applying steering to do that, we would predict where we wanted to end up in lane 2 50 yards ahead, and then just get the computer to produce a really nice smooth curve for us, S-curve, and then just plot that as the new direction, and it would handle the translation very smoothly, both for throttle and for steering. But then, what was your question?
What was the, was this all simulated?
Some of it was simulated. The beginning parts were all done in simulation. Parts of it based off of really Stanford's and then Google's self-driving car program, which is now Waymo. The guy who started this program is the guy who headed up the Google self-driving car project. So there's a lot of overlap there.
Oh, cool.
The testing for things like this, the local streets, particularly when you're going up and down hill where the lane lines disappear and then show up, partially because you don't want people in the car in your beta or alpha software driving off the cliff like we were talking about. The testing itself took place on a track. There were signs to identify, and then finally the video that I showed you was just in a small parking lot, a gravel parking lot.
With a real car.
With a real car. Objectives in the way, obstacles in the way you had to avoid, stoplight that you had to identify, stop for, once it turned green, identify that, continue,
so
not hit the fence.
Pretty full self-driving.
It was, yeah. It was a restricted test zone, but pretty much all the controls are self-driving.
What was the class called? Or what was it?
So it's the Udacity Self-Driving Car Engineering Nanodegree. So it's like a master's degree, but just it's 10 months long rather than 2 years. It was also significantly cheaper than in person.
All online?
All online. The majority of the teachers were from Georgia Tech. They're the ones who really headed up this particular nano degree because they have artificial intelligence nano degrees and other things there. But then they also had guest lecturers from NVIDIA, and that's where I was learning a lot about the Drive PX system.
Yep. That's what this car has.
From Mercedes-Benz, from Uber, from a number of other companies that work on autonomous driving, who would just teach one particular section that they tended to focus on in their real-world engineering efforts.
Very cool. How many people in the class?
Thousands.
Thousands?
Yeah, so I headed up a final project that was just a team of 5. So we worked together to create our software that they then ran on that Lincoln. But across all the teams and all the cohorts, the semesters, effectively, probably thousands.
What was the core software language? Or
mainly with Python, using Google's TensorFlow and Keras libraries for neural networks, and then a lot of Pandas and SciPy libraries for doing data analysis and regression modeling. The actual car itself ran on something called ROS, the Robot Operating System. So we're feeding commands developed in Python and C++, neural networks, to the ROS operating system to translate that to the car controls.
Very cool.
A lot of different pieces. It was a challenge. It was a good 10 months of work, that's for sure.
Well, thanks so much for all the info. No problem. Awesome. No problem.
I had a lot of fun.
Hopefully, yes. Thanks again for watching. My videos for the Model 3 are here in the top right. My son's channel, The Nerd Writer, is in the top left. Check him out. He's got some really good videos. And please don't forget to subscribe. Thanks, everyone. Bye-bye.